Biomedical instrumentation is used to measure and monitor different physical variables like heart rate, blood pressure, temperature, respiratory rate, and muscle extension, which is it helps healthcare professionals assess a patient's health status and make informed decisions about diagnosis and treatment. These are the purpose about e-health biomedical instrumentation system. The first one is electrocardiography, which is ECG, a low-cost measurement of electrodiagram monitoring system using Arduino for real-time patient monitoring hospitals and home. The system accurately detects ECG waveform and provides reliable heart rate measurement, showcasing the potential of Arduino in improving healthcare access. The second one is electromyography, which is EMG. EMG measures muscle activity and it is used to diagnose and evaluate muscle and nerve disorder like ALS and carpal tunnel syndrome. It can also monitor progress and assess treatment effectiveness. The experiment measures EMG signal generated by the bicep during isometric arm extension.
The physical factor discussed in the journal e-health are crucial health indicators that can be used to identify and correct a range of medical disorders. Blood pressure is measured using an inflatable cuff and a pressure sensor. Oxygen saturation is monitored using a pulse oximeter. The absorption of this wavelength by oxygenate and dioxygenate hemoglobin determine oxygen saturation level. Electrocardiogram ECG measures the heart electric by activity detecting in electrical signal generated by the heart during each heartbeat. Electrodermal activity EDA, also known as a galvanic skin response (DSR). EDA sensor measure the skin electrical conductance influenced by sweat production and nervous system activity. Electrocardiogram EMG measure the electrical activity produced by skeletal muscle during contraction and relax.
Moving on to the measurement system elements that are used in this instrumentation. There are two types of sensor used. The first one is electrocardiography or ECG sensor. This is used to record the heart activity during a certain period. ECG signals can be recorded from two differential electrodes placed on the chest. The heart rate is calculated by counting the peaks that correspond to the heartbeats per minute. The next sensor is electromyography or EMG sensor. It is used to measure the contraction of the muscles. EMG signals generated on the activation biceps by performing isometric extensions. Then, the percentage of the exerted force is calculated by dividing the EMG's amplitude in real time with previously measured MVC, which is subsequent of EMG signals. The next element is signal conditioning. Arduino Uno is used to enhance the quality and accuracy of the signals from the sensors. This may involve amplification, filtering, noise reduction, or impedance matching to optimize the signals for subsequent analysis. Next is signal processing. Arduino Uno connected with eHealth sensor shield are used to perform real-time processing and analysis of the signal. They are implementing algorithms for signal filtering, feature extraction, pattern recognition, or abnormal behavior. After that, a DC element is contained in digital oscilloscope is used to measure the voltage waveform and amplitude of the processed signal and converts it into digital value. The data converted then displayed using time in x-axis and amplitude in y-axis. The processed data is transferred to the computer by using USB cable through the Arduino USB port. Let's move on to the next part.
This is the block diagram of eHealth biomedical instrumentation system. Certain characteristics which are common in most instrumentation systems are also applied in biomedical instrumentation system. Any medical instrumentation system would be made
up of the following key component, which is measurement, sensor or transducer, signal conditioning, and display system. Measurement is physical quantity and instrumentation system measure it. Human body acts as the source of the measurement and it generates biosignals. For example, surface of blood pressure in the heart. The next one is sensor or transducer. The transducer converts one form of energy to another form, usually in electrical energy. For example, piezoelectric signal, which converts mechanical vibration into electrical signal. The transducer produces a usable output depending on the measurement. It is used to interface the signal with the human. For signal conditioning circuits are used to convert the output from the transducer into an electrical value. The instrument system send this quantity to display or recording system. Generally, signal conditioning process includes amplification, filtering, analog to digital, digital to analog conversion. Signal conditioning improve the sensitivity of the instruments. For the display system, it is used to provide a visual representation of the measured parameter of quantity. Example, cathode ray oscilloscope. Sometimes alarms are used to hear the audio signal. Data storage is used to store the data and can be used for future reference. Recent days, electronic health records are utilized in hospital. For the data transmission is used to telemetric system where data can be transmitted from one location to another remotely.
Wheel of material, I'm going to explain about function of the components. For the firstly, we're going to look about the Arduino. Arduino board serves a main control element, executing programming codes and an ability to communicate with other components. It is connected to a computer via USB for the power, data transfer, and programming purpose. Function generate is an electrical wave from a circuit testing. And analogical signs are converted to a digital value using analog to digital convert ADC for processing by the microcontroller. For the microcontroller acts as the brain for the project, executing to command and reading sensor input and manage output device. Circuits are diagnosed is performing using a multimeter to measure voltage, current, and resistance. An oscilloscope is used to view and analyze the electrical waveform. The power source provide the necessary electrical energy and the wave of creating the electrical connect between the components. An oscilloscope is used to view and analyze the electrical wave. The power source provides the necessary electrical energy and the wires create the electrical connect between the components. In medical field, electrodiagram ECG sensor detect the heart electrical activity using the skin. Electrodes help in identify the heart disease. For the electromyograph, EMG sensor monitor the electrical activity of muscles, helping in assembly of muscle function, disease detector, and therapy or exercise monitoring. Both ECG and EMG sensor are critical diagnostic instruments in medical.
The first application of e-health biomedical instrumentation is electrocardiography. Electrocardiography is the system that can be measured and analyze the electrical activity of the heart, providing insight into heart rate, rhythm, and abnormalities. It can help in diagnosing and monitoring heart conditions such as myocardial infarction and heart rate variability. Second application is electromyography. Electromyography is the system that can be measured and analyze the electrical activity of the muscle, enabling the assessment of muscle function, activation pattern, and detection of neuromuscular disorder. It can be used in sports science, rehabilitation, and assistive technologies. Next one is respiratory rate monitoring. The system can measure and analyze respiratory rate, providing information about breathing patterns and detecting abnormalities. It is useful for monitoring respiratory conditions, sleep disorders, and evaluating the effect of breathing treatments.